Hey guys, this is Aaron with iBoard Repair and iPhone Data Recovery, and today I'm working on another iPhone 12 Pro. I haven't done too much to this phone other than take off the front screen, and I did my first initial diagnostic step, so let me show you what that was. It's a problem I'm very familiar with. If you keep an eye out on my DC power supply here, this is always my first step when I'm working with a completely flat dead phone. All I've done so far is probe the battery connector and see what kind of amp draw it gives me. Let me test with my multimeter what side is ground. I do tend to forget. The right side's ground. So when I touch my probes to the battery connector, I get a full amp draw. You can see this on my DC power supply up here. This indicates usually a VDD main short, possibly a couple of other lines. So we'll do some measurements and we'll see what line is short on here and we'll see if we can fix it. Okay, I have this motherboard out of its housing, so let's take a look at it. First off, I guess I can show or see if it's still giving me this full amp draw. And yeah, it's still giving me the full amp draw, so I still have a main type short on here. It may be main, it may be boost, it may be a couple of other things. We'll be able to check that out. So first I want to measure VDD main and see if I actually have a short on that line itself or if it's going to be on a different line. I know I have main underneath this sticker, so I'll just pull this up and double check it. I believe it's this row right here is main. And I do not have a short on main. Since I don't have a short on main, that probably means I have a short on boost. So let's see where I can find boost. I'm going to pull up my board view software so I can double check that. So I'll open up, this is the 12 Pro Max, so I'll open up the 12 Pro. Yeah, so that was main there. I have boost. Let's see. Here's boost. This is probably going to be short, I'm imagining. Looks like I have some test points on the back of this board, so I'll just check on there. So I have these two little dots, these two, so boost should be in this dot right here. I expect this will be short, so let's see. Boost is also not short, so that's interesting. I don't have a short on main and I don't have a short on boost, but I do have a full amp draw before prompt to boot, so I have a short somewhere. So what else could that be? So in this case, I think it's smart to check with my thermal cam where the heat might be showing up. So I'm going to touch the probe to the battery connector and see if I can find some heat. I'm getting immediate heat. Can you see that? Right around this area. I'll double check that. I'll look at the top, make sure there's nothing up there. I'm not seeing any spikes of heat up there. But right here, I'm definitely seeing a spike of heat. Yep. So that's going to tell me it's on the inside of this board. Also, that seems to be right at the VDD boost chip area, but I already checked VDD boost and it's not short, so I'm not quite sure what I'm going to find when I open this. But I'm going to split this board and let's see what we can find. Okay, I've got my board on my hot plate here. I'm going to set my temperature to, I like 235, but I never measured this. It might not be calibrated perfectly, so your temperature may be different. I've heard others do it at about 220. I'm going to let this heat up. It takes quite a while for this model. I have to let it sit on here for about 7 or 8 minutes usually for it to get to the right temperature. So I won't make you wait with me. I'll go ahead and pause the video and I'll come back right before I pull it. Okay, I don't really think it's quite ready, but I always like to check early just to be sure. I'd rather it not get too hot. No, it's not quite ready yet, but it's getting close. In a couple more minutes it should be ready. Okay, any second now this thing's going to be ready. There it goes. Okay, I'll take a look at it. You know, sometimes the board view software is just wrong and it doesn't know what line is what. And because of where that heat was showing up, I kind of think this may still just be a boost short. I could be wrong, but that's the first thing I'm going to check is boost, see if it's short. I'll clean off the board a little bit first. I guess before I check that, I'll still make sure, or I'll make sure I'm still getting an amp draw from the battery connector. If I'm not, that means the problem was on the bottom half of these two motherboards. But I expect I'm still going to have an amp draw. And I do. So I'm going to check boost first just because, like I said, that's where it looks like the heat's coming from. So which line is boost? These two capacitors right above the boost IC are on the boost line. And nope, not short. Okay, so I was wrong about that. Interesting. The heat was right here. So I'll just go ahead and inject into VCC main and see where I can find the heat. I still expect it's going to show up somewhere right around here. So So I'll find main first and then I'll inject into there. So these two caps are main. They're not short, but I'm going to inject into there. And first, let's make sure it gives me an amp draw when I do that. When I do, I get an amp draw. So that amp draw will give me heat somewhere. So let's just see where the heat goes. Okay, so Yangtze, my charging IC is bad. Interesting, that's the first time I've seen that. Let's look at specifically what lines we're dealing with right there. Let's see if I can get a measurement and find anything short. So the chip may be bad, but it may not be bad. It may just be a line that feeds into there and it connects to main through that line. So that would heat up the chip, but it doesn't necessarily have to be that chip. It could be something else. So the LX charger P2 line is not short. Let's see if the LX charger P1 line is short. That line is also not short. And there's a 6-volt charger LDO line. Let's see if that line is short. That line is also not short. I'll check just a couple more because I don't want to pull the chip if it can possibly be something else. So PP charger PMID line, let's see if that's short. Yeah, and that line is short. So now if I inject into that line, it will confirm for sure which line is actually the short line. If my chip still heats up, then I suspect it will be, just a bad chip. But let's see what else this can possibly be, if anything. There's a few capacitors. Yeah, it's either going to be one of these capacitors or it's going to be the chip itself, it looks like. So I'll go ahead and inject right into there. And we'll see right away. If this chip heats up, then the chip is the problem. If not, then I have capacitors under here and they're likely the problem if this chip doesn't heat up when I inject. I'm not really sure. Let's see if there's schematics so I can see the proper voltage that this is supposed to be on. I'll probably bring it down no matter what, but it doesn't even look like there's schematics. I'm just going to do something small, like a 0.8 volts. It's probably fine to take the full 4 volts. I'm just not 100% sure of that, so no point in taking the risk. I'll see like point, yeah, whatever that is, 0.8 almost. So where's the line? Okay, so let's see. I think it will be the chip, but I'm not 100% sure. I just want to make sure. The voltage is actually looks like 0.65, so that's what I'll be injecting. Maybe this may have been a smart thing to do because I'm not sure that this chip's actually going to heat up. Yeah, so it doesn't look like the chip itself is bad, in my opinion. I could be wrong, but I'm going to pull the shield on the front and check those capacitors instead. All right, let's see. I'm gonna get rid of the underfill along the outside of the shield. That's not even underfill. That's just flux, possibly. There's underfill on this side. Okay, there's only a few caps it can be, and it looks like already that it's this one, because this can be the cap that's bad. It can be this one, this one, this one, or the one in between it. And this one is very discolored. Now this is very interesting. I've actually never seen this problem. So I'm very glad I didn't mess with that charging IC, because that would have just led me down the wrong path, because it's almost surely that capacitor that's bad right here. So this one, this one, this one, they're all going to measure bad right now. I'll show you that. So ground, 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 ground. I can clearly see which one's bad, but I'll go ahead and inject just for fun. So when I inject voltage into this capacitor, that one is going to be the one that heats up. It is a very slow bad signal because I'm using low voltage and I didn't freeze this board enough. Let's see if I can get a better reading or like sign than that, because that wasn't very clear. It still did heat up at the very last second. Let's just see if I can get a better one or not. If not, I'll just still pull it. Again, it's giving me a very, like, not a good signal, but there, it heats up before that one and they're on the same line. So that would tell me, I think it's mainly just because I'm using a low voltage. I think this would be fine with a higher voltage, but anyways, doesn't matter. Yeah, look, the cap just fell apart. I'm not sure if there's still like continuity going through the bottom of that cap, but it's kind of hard to tell. I'll just measure it and see if it's still short. And no, the line's no longer short here. No longer short here. This is ground on this side, and then no longer short here. So that fixed the problem. This is going to allow me to pull data now, which is the main goal of this customer. I may still fix and reball this board, depending on what the customer wants to do exactly, but the main priority is data recovery, and this is going to allow me to pull it. I'll go ahead and grab a screen, battery, and charge port just to verify it still turns on and show you guys that. Okay, I have my battery, screen, and charge port here, so let's just make sure it turns all the way on. I don't expect any more problems at this point. There it goes. So we have an Apple logo. Let's make sure it gets to full boot. And the screen's always going to go dim when you don't have the proximity sensor plugged in, but it is booted up, and it did take the passcode. It's fully booted. So yeah, that's great. I'll be able to pull data from this. Customer will be very happy. So this one's a very interesting case because the first initial diagnosis kind of shows what normally would be either a VDD main or a VDD boost short, and that wasn't the case with this one. I was able to see where the heat was going by using my thermal cam and knowing I have to split this board. And then once I split the board and I saw that the heat was going to the Yangtze chip, the charging IC, formerly called Tigris, most people would probably just pull that chip and assume that it's bad. But I realized that the chip was connecting main to the line that's actually shorted, or that could potentially be the case. So I decided to check the lines close to where that heat was showing up underneath that chip, and I was able to see that the charger PMID line was short, and injecting directly into that line shows where the heat's really going. So that was a great job. I'm glad I found this. I'm glad I didn't pull that chip because I would have had to pull from a donor because I don't have any new ones of that one. So I'm glad I avoided that. And I'm glad this one worked out. So thanks for watching my video and hope you stop by again. Have a good one. Bye.